In this presentation, let us try to understand how to identify the given carbohydrate solution as sucrose. Coming to the physical properties, state is liquid, sucrose is colorless, odorless compound, and reaction to litmus is neutral. So these are the different tests we need to perform to identify sucrose in the lab. Coming to Molish test, this is a general test for carbohydrates. So it gives violet ring at the junction of the two liquids. It indicates the presence of carbohydrate. What's the principle behind this test? Carbohydrates, when treated with concentrated sulfuric acid, undergo dehydration to form furfural derivatives, which condense with phenol alpha naphthol to form violet colored complex. Next, we have to find out whether this carbohydrate is a monosaccharide, disaccharide, or a polysaccharide. So we have to do iodine test. Here in this, for this sample, there is no color change, so it indicates polysaccharide absence, so it may be a mono or disaccharide. So next test we need to do is Benedict's test. This test is done to identify the presence of reducing sugar. For this sample, there will be no formation of colored precipitate, so it indicates the absence of reducing sugar, so non-reducing sugar may be present. So next test we have to perform is acid hydrolysis, where blue litmus paper turns red. Now the principle behind this test is when we add acid or heat the solution, the sucrose present in the given solution is broken down to glucose and fructose, and the resultant solution is known as acid hydrolysate, and with that we have to perform Benedict's and Selivanus. Why we have to perform Benedict's test is because sucrose is made up of glucose and fructose and both are reducing sugar. That's the reason why we have to perform Benedict's test. And why Selivanus test is, so fructose is a keto sugar. To identify the presence of keto sugar in the acid hydrolysate, we have to perform Selivanus test also. So when Benedict's test was performed for this sample, we have got a yellow colored precipitate, and this indicates the presence of reducing sugar in the acid hydrolysate. So what's the principle of this test is reducing sugar in hot alkaline medium, especially the glucose and fructose present in sucrose, are converted to NADOLs, which are powerful reducing agent, and they reduce the cupric ions of Benedict's reagent to cuprous oxide, which forms the colored precipitate. Coming to the principle Selivanus test, we get to see cherry red color here. This indicates the presence of ketones. So what's the principle of this test? Resorcinol present in the Selivanus reagent react with furfural derivatives to form cherry red color complex. So how to report this sample? The given solution is carbohydrate, non-reducing disaccharide sucrose, which on acid hydrolysis gives glucose and fructose. Now, sucrose. Coming to sources of sucrose. Sucrose is mainly present in sugar cane, fruits, and small amount of sucrose is also present in honey. The other processed sources of sucrose include the table sugar, ice cream, desserts, etc. Now, sucrose is non-reducing because the linkage involves first carbon atom of glucose and second carbon atom of fructose. So, both the function groups are involved in formation of glycosidic linkage, and that's the reason why sucrose is a non-reducing sugar. Further, sucrose is also known as invert sugar. This is because hydrolysis of sucrose changes it from dextrorotatory to levorotatory compound. So consider this line reaction where sucrose is broken down to glucose and fructose. Sucrose has optic activity of 66.5, whereas glucose has 52.5 and fructose minus 92. So when sucrose, initially a dextrorotatory compound, gets hydrolyzed to glucose and fructose, it gets converted to a levorotatory compound. That's the reason why it is called as invert sugar. So this was all about identification of in the lab. So this presentation was done by Dr. Preeti, Professor of Biochemistry from JJ Medical College, Davangere, Karnataka. Here are the links to other practical biochemistry sessions. You can access the biochemistry practical session by clicking on this link. Thank you.